Now we're going to remind ourselves on how to graph slope-intercept form. As a reminder, slope-intercept form is y equals mx plus b, where m, or the coefficient of x, or what you're multiplying by x, is the slope of the line. Remember, slope is rise over run on a graph, and b is the y-intercept. The y-intercept is where the graph crosses the y-axis. Our essential question today is, how do we interpret the slope-intercept form of an equation? When we're graphing in slope-intercept, the first thing we want to do is identify what the slope and the y-intercept are. The slope, remember, is what you're multiplying by your x variable, and your y-intercept is the value that you are adding or subtracting. Make sure that you keep that sign in front of it. So if it's -5, as in this case, our y-intercept is -5. We're going to start by graphing the y-intercept, so we're going to go down 5 on the y-axis and plot our first point. From that point, we're going to use our slope as rise over run. In this case, our slope is an integer, so we have to turn it into a fraction so we can have rise and run. Anytime you have an integer, you turn it into a fraction by putting it over 1. From the y-intercept, we're going to rise 2 and run 1. I like using the slope over and over because my lines tend not to be very straight, so the more points I get on my graph, the better my line looks. We can also go down 2 and left 1. Remember, a negative divided by a negative is positive, so when you go down and left, your slope is still positive. And then you simply connect all of those points in as straight a line as you can make. And that's the graph of the line. As a reminder, every single point we just plotted will make the equation of our line true, including all of those points in between the nice integer points we found. So fractions can make this equation true as well. Our next equation, the slope, what we're multiplying by the x, is 1/3. Our y-intercept, what we're adding or subtracting, is -5. So again, we're going to start with that y-intercept. We're going to go down 5 on our y-axis. And from that point, we're going to rise 1 and run 3. I'm going to continue to rise 1 and run 3 for the whole graph, as well as fall 1 and go left 3 to use the whole graph off to the other side. And that way I can make a line that looks fairly straight. Next, we have a slope of -3/4. A lot of students tend to have difficulty graphing a negative slope, and I'll explain why in a minute when we put that on our graph. Our y-intercept is +1, so this time we'll start up 1. What a lot of students like to do with a negative slope is go down and left. But remember, when you're heading down, that's negative, and when you head left, that's negative. A negative divided by a negative is positive, so you end up with a positive slope when you go down and left. You can choose one value or the other to make negative, but not both. I'm going to start with making my 3 negative, so I'm going to go down 3 from my y-intercept, and I'm going to go right 4, so that my slope is negative. A negative divided by a positive will give me my negative slope. Another way to remember this, when you're done graphing your line, if your line is rising from left to right, then your line has a positive slope. If your line is falling from left to right, then your line has a negative slope. We can also treat the 3 like it's positive and go up 3, and treat the 4 like it's negative and go left 4. Notice how the lines for the first 2 examples were rising from left to right because they had positive slopes, and see the difference in this line that is falling from left to right because it has a negative slope. You have 2 U-Try questions today.